Okay, last time we looked at a bunch of different scenarios on your sheet. A tax, a subsidy, a price ceiling, a price floor. A price floor with government expenditures was the last thing that we left off with. And we were kind of showing how we get similar results depending on the policy with the deadweight loss, the magnitude of the deadweight loss, which was the kind of the overall loss to society after we take into account what the government gets, what households get, and what businesses get, taking that into account. So economists being a little discouraged by the crazy policy that Congress put into place by buying the excess corn that they didn't figure out ahead of time would happen, developed a different program called the target price program. So that's what we're going to look at next, our last one. And so I wanted to start on the board to kind of highlight how the program is different from what we did in the previous column. So with the price floor, let's walk through the logic again. Government says, whoa, corn prices at $4, that's way too low. Let's fix the price at $5. Corn prices can't be any less than $5, instituting a price floor. Producers produce 120 bushels of corn, but consumers aren't willing to pay $5 for that quantity, and so we have a surplus. That surplus then had to be purchased by the government because they were trying to help the family farm, not hurt them. So they're like, hey, we'll buy it because we have to. And then the government spent this big chunk of money in order to buy up the surplus. And then that's what we were left off with. All right, so here is a different approach called the target price program. Number one, government sets the target price, PT. Government sets the target price, PT. For this example we're going to do, they're going to say, hey, farmers, target price this year is $5. Step number two, producers, the farmers, produce, build, make, create. What am I trying to say? Produce. I was trying to get away from that, but wasn't clever enough to come up with something. Producers produce as much quantity as they wish, i.e. the quantity supplied, Q subscript S. Producers produce as much as they wish, knowing they will get the target price. They will get PT, the target price. So far, is the story any different than the price floor? Not really, right? Not really. So right now we're at the same. So step 1 and 2 is the same. Step number 3 is that the producers sell all inventory to consumers at the highest price they are willing to pay. Producers sell all inventory to consumers now at the highest price they are willing to pay. Let that price be called the market price. Let PM be equal to the market price. Step number 4. The government's going to make up the difference with what they call a deficiency payment. So government pays the producer a deficiency payment. A deficiency payment equal to PT minus PM, the target price and the market price. So they're going to make up the difference to them. The target price was 5, we know. And so if consumers were only willing to pay $1, then the government's going to cut them a check for $4 for every one that they sold. So they're making up the deficiency. That's why it's called the deficiency payment. Market price, yep. What's that? So, good question. If the market price is higher than the target price, there is no deficiency payment. So note, if the market price is greater than or equal to the target price, then there's no deficiency payment. Then deficiency payment equals 0. We're not going to pay a deficiency payment because the market was already paying them the $5 that they were guaranteed. All right. Any other questions on the setup of this program? All right, let's do it. Let's do it. Let's see where we're at here. So back to our friendly little diagram we got here. We are going to now set the target price at PT equal to $5. Sorry, I got this big fat marker. I meant to grab a little narrower marker, but PT is now equal to the $5. How much are producers going to make? They're going to earn $5 as the price, right, per unit. And what quantity are they going to produce? 120. So I just want to highlight that at that price, they make 120. All right. What is the market price? $3. So the demand curve tells us the price that people are willing to pay for 120 units. We go up to the demand curve, hang a left, and that now establishes the price that will clear the market, that will buy up all of the 120. So PM gets determined by the market at 3, giving us a deficiency payment of $2. All right, so let's do the welfare analysis for that. So, relative to a free market, like we've done this whole worksheet, so the consumers started off with what? A, B, and C. So yes, the way we started this off was a free market is ABC. Producers have F, G, J. And now, what is the change in consumer surplus? plus F, G, H, and I. Correct. Consumers are buying 120 at a price of $3. So starting from left to right, what they're willing to pay is up here maybe, but what they actually pay is $3. Willing, actual, willing, actual, willing, actual, willing, actual, willing, actual. The new consumer surplus is this big triangle, which means the change was F, G, H, and I. So F plus G plus H plus I. Good. All right. Producers. Plus BCD, good, because they used to have FGJ. Now the difference between what they actually get, which is $5, and the minimum amount they must get, which is the height of the supply curve, actual minimum, actual minimum, actual minimum, actual minimum for all 120 units gives us this new triangle, which means they added B, C, and D. Government revenue. Change in government revenue. I heard a B? Minus E. I'd agree with that. Partially. D? And E? I'd agree with that. Partially.
Is this the entire box?
Okay, what entire box? Start talking to me.
From
Just label, name them off.
B, S, C, D,
B, F, C, G, H, I, E, D. Good. That is correct. So the government is buying nothing, but they are paying $2 for every unit that producers sold. So they are giving a deficiency payment of 120 times the height, which was the $2 deficiency payment, giving us that big rectangle. Since they're paying the money, we enter it in as a negative sign again, and we get a minus B, minus C, minus D, minus E, minus F, minus G, minus H, minus I. We got a big mess on our hands. Now we get to see what the welfare effects for society were by adding them up. But we see that the plus B and the minus B cancel out, the plus C and the minus C cancel out, the plus D and the minus D cancel out, the F, G, H, and I, well, those kind of conveniently cancel, and we add them all up and we're left with minus E. So from a policy standpoint, in terms of deadweight loss, which program's better to help the farmers? The target price or the price floor? The target price. Because the E and the E are here, it's a no-brainer that this is a better program with less waste. Now, we got to be careful when we say that, because the intent of the program was to help who? Producers. Now, do they care if we go with this program or this program? Does one program make them better off or worse off? No. How do you know that? B, C, D, B, C, D. So the farmer is indifferent between these two programs. What are the consumers going to do? Are they going to like this better or not? Well, pretty obviously here they were losers on this one. Pluses all the way around. So it's this program relative to this one is what we call kind of a no-brainer, that this is way better idea. And you see that I took the same parts, but we implemented a different program, right? We got the desired result, at least didn't make it any different, of helping the farmers, but we got it in a different way by using some economics and thinking about incentives and how we might be able to design a better program to get our final outcome that we were looking for. Okay, now, if you carefully eye all these columns, what can you tell me about the target price? Yeah, same as this one, but they're not. How are these two programs different from each other? This is again kind of a devil in the details type thing. Yeah?
The subsidy has a set amount of $2, whereas the target price is much lower.
Excellent, excellent. Yeah, that's right. So the design of the program is different. This particular outcome that I highlighted for you has the exact same implications. But that's not true over the long haul, because as the demand for, maybe I'll just go with my pencil instead of golf club here. I'll stick with the overhead. If we come over here, as the demand, if the demand increases from here to here, what happens to the deficiency payment? It decreases, right? So the deficiency payment is this vertical distance here with that with that bar. So the deficiency payment shrinks. The subsidy would still be floating in here. Remember my little and get wedged in here because it's a $2 subsidy? If the demand curve even went up to here, how much is the deficiency payment? Nothing, right? So the new demand curve intersects the supply curve. Consumers are willing to pay $5 for the corn, and producers have made that much corn. The market clears, deficiency payment disappears. Now the beauty of this here too is that it strips out the discretion from Congress of having to make another act, right? Has Congress been getting along with each other very well the last 4 years, last 8 years? They come to terms, they figure things out, they come to agreement, you know? No. But here what we've done, if we can get people to agree to this policy, it's on autopilot, isn't it? If the market changes, the deficiency goes away, and guess what? The farmers don't cry because they knew that they got their corn sold at $5. It wasn't a big deal, right? It was all set up ahead of time. So it's kind of a non-discretionary policy. It doesn't take the act of a politician or somebody else to change the rules. Whereas with the subsidy wedge would be climbing in here, and it would get wedged right in here. And now the farmer would still be getting paid the subsidy at $2, and we kind of have a similar problem to what we had before. And to undo the subsidy might take an act of Congress. Oh, we got to legislate about this. Well, who's going to lose? Who's going to win? You know, what if the subsidy gets reduced by $1 or something, and it takes an act of Congress to change the subsidy? So those are some significant ways that the subsidy is different from the target price. It's a very, in a kind of a dynamic way as we start to think about how the market evolves, that it'll adjust on its own. Yes?
Now, from a policy standpoint, if there's any risk of the demand decreasing, then they would prefer a subsidy. So if the demand decreases, doesn't that increase?
Okay, let's look at that.
Deficiency payment?
So let's go the other direction. So we're trying to help farmers out, and if the demand falls to the left, what happens to the deficiency payment? And I might have went a little too crazy here. If demand falls to there, what happens to the deficiency payment? It goes up, right? And if our intent is to help the farmer, then we're still serving that purpose. All right, so which do you prefer as a farmer, the $2 subsidy or the deficiency payment? You get the same amount. Well, not comparing a subsidy versus the deficiency payment.
You prefer the deficiency payment, but from a policymakers.
Okay, good.
prefer this.
That's right. So we might face higher government spending with a decrease in demand. There's a bigger check going out in the form of a deficiency payment with a decrease in demand. But then it comes back to what's the intent of the policy. If the intent of the policy is to help the farmers, then having the deficiency payment grow, yes, it might put a bigger strain on our overall budget as a government, but we're still satisfying the intent of the policy. And from kind of maybe a bigger perspective, especially when we talk about agriculture, as the economy grows, the demand curve tends to shift to the right through an increase of our shifters, which are taste of preferences, income, population. I heard number, but it's population, not technology. That's on the supply side. Price of related goods with the demand side, expectations, right? Those sorts of things. As income goes up, as the economy expands, and if there's growth and there's more income, the demand curve will tend to shift to the right, which would tend to, at least from a betting standpoint, that the deficiency payment will tend to get smaller as the economy grows rather than larger. Okay. Good. Anything else? All right. So on the just kind of FYI, I think I maybe mentioned this towards the end. On the back side of that figure that you guys had with your supplement, that stuff is written out here on the different programs and each one, so that you can review that at a later time. All right. So let me write that down so you guys have that in your notes here on the target price program versus deficiency. Or subsidy, yes. So note, target price and subsidy look the same. But are different as the market changes. For example, an increase in demand, a big enough increase in demand will lead to smaller deficiency payments. But a subsidy would remain the same. Okay, let's see, the last thing I want to hit is, and we mentioned this slightly, how elasticities play a role with these welfare estimations. And specifically, I want to look at the burden of taxation. So tax burdens and elasticity. So first of all, the tax burden is who does the burden of the tax fall on? So who pays the tax? The reason that's relevant is that we've learned that the tax burden is shared by consumers and producers. Taxes are shared by consumers and producers, regardless of who is assessed the tax. That is a real big takeaway from this that you should remember the rest of your lives, not just to get past the next exam, but this is a big one. Because when we go to tax those big bad banks or tax those corporations, the lessons here are real important, that the consumer inevitably pays part of that tax too. It's all buried into the numbers, buried into the prices perhaps, because the cost of doing business has gone up. We've learned that that'll drive the price up. So the consumers end up paying the burden of the tax to some degree, unless we're at one of our extreme cases, which is kind of what we'll get at, and how elasticity plays an important role with that. So for this one, let's go ahead and put 3 graphs side by side with each other. And in this graph, let's draw a real steep demand curve with kind of an ordinary supply curve. With this one, let's draw a pretty steep demand curve and a pretty steep supply curve, about equally sloped. And on this one, draw a pretty elastic demand curve, fairly flat, with maybe just a regular old supply curve. Go ahead and draw your quantities, your initial quantity and your initial price where the 2 lines cross. So the starting place in a free market, free from government intervention at this point. And what we're going to do is apply a tax to each one of these markets. The amount of that tax is going to be the same for each one. And I'm going to use the tax wedge approach. So remember, we talked about shifting the supply curve up by a certain amount of the tax, or if the consumer's being taxed, we might be shifting it down. So we can do it with the shift business. But I actually kind of prefer the tax wedge, mostly because I like floating this wedge in here. So the tax wedge, the edge of this eraser is reflecting a vertical height here that represents a dollar amount. So maybe this is a $2 tax here. So the edge of the eraser is the $2 tax. And we're going to float in the little tax wedge, staying above the supply curve and below the demand curve. Keep floating, floating until it gets wedged in there. And where it gets wedged, the top part touches the demand curve, telling you the price that the consumer pays, and the bottom part touches the supply curve, telling you the price the producer receives. The edge of the wedge again is the per unit tax. So you guys on your papers, your lines might be different. Also, don't forget to put in the quantity after the tax, the little QT down here. So the quantity will fall once the tax is implemented. And as we float it in here, somewhere in here it gets wedged. And we do the same thing. And then finally we float in here, right there. And we get the price that the consumer pays and the price the producer receives. All right, so for each of your papers, just go ahead and do that same vertical height. Float your wedge in and mark up your papers accordingly. Okay, so the burden of the tax is the amount by which each party got kind of hurt. Under a free market, we had this price going on, and now consumers are paying this price. So we can take the tax, remember this whole rectangle represents government revenue. Effectively what we've done is that the consumers are paying this share of it because their price went up from P1 up to this. And the producers are paying this amount, the green portion. So the green represents the producer's burden, and the blue, the consumer burden. So blue equals consumer burden, and the green represents the producer burden. And we can do that for each one of these. So the up top, that's the producer or the consumer's chunk. Here's the producer chunk. Here's the consumer chunk. Here's the producer chunk. All right. What determines who bears the burden of the tax? Can anybody put that into words now? Now we see how it shifts around. Who could put that into words? Egg? Okay, good. I'm glad you said the elasticity of demand and supply. So it's not just depends on the elasticity of one or the other. So can we make the statement that if demand is inelastic, relatively inelastic, then consumers will definitely pay more of the tax? If demand is more inelastic, or relatively inelastic, will consumers for sure pay the burden of the tax? The answer is no, and that's correct, which is a little counterintuitive. Why? It depends on the supply too, because and that's kind of what this middle one is showing here, is that as I change, if I was to change the elasticity of supply here, and make it more inelastic, as I start to make it more inelastic, do you see how this box is going to float down? All right? As that becomes more inelastic, the box is going to float down, and the producer's burden is going to increase, the consumer's burden is going to decrease. So it's one relative to the other is the important point. Here we've got two that are pretty steep and they're pretty equally sharing the burden. What if the demand was perfectly inelastic? Now what would happen? Producers would pay more? Consumers would actually pay it all. If this was perfectly vertical, if it was perfectly inelastic, so we're talking maybe crack cocaine, right? So if I can pass a tax on crack cocaine, those crackheads still want the stuff no matter what the price is. So when I float my little tax wedge in, all nice and friendly like, right? I need to go all the way over, and what's going to happen is that those drug dealers aren't paying any of the tax, and the crackhead's paying it all, right? So it's the elasticity of one relative to the other, not one in absolute value in terms of what it is, but it's always one relative to the other that determines the burden. Here we have the demand curve being relatively elastic. The producer is bearing the burden of the tax, but if I start to make the supply curve more elastic, what's happening to the green box? Is it getting bigger or smaller? Smaller. And in fact, what if it was perfectly elastic? Who's going to pay the tax? The buyer. And in fact, in this particular case, we might knock it out of the market, so I kind of went too obnoxious here. But if the tax was smaller, the consumer would pay all of the tax. So it's always one relative to the other. So let's write that down. Questions on that? All right, so the answer to that question, that could be very similar to what you'd see on a test. The answer, who pays the tax? It depends on the relative elasticities of supply and demand. Now, the simple layman's way of remembering this is the relatively steeper curve will pay more of the burden. The relatively steeper curve will pay more of the tax. The other thing I might note here is a homework problem similar to what we were doing. They might ask you to calculate what is that burden, which is just some numbers again. If this ended up being 100 after the tax, and we used to be at $10, and now the tax has caused the price to rise to $14, this blue area, we can calculate the value of the burden of the tax, right? So it's $4 times 100 is $400. Consumers are paying $400 of the tax, while producers might be only paying 2 times 100 is $200. They're paying $200 of the tax. The total tax is the area of the whole thing. Okay, we're just carving up the pie. All right, so that is it for this Sunday's stuff. That wraps up chapter 4 and 5. Okay, so you got your test coming up. Hopefully you've hit some of your homework. It looks like some of you are making some progress there. And we now get to take a dip into happiness.
Russ?
Yes?
So when curve either demand, so if demand is perfectly inelastic, then the consumer has the entire burden of the tax?
Yes.
And then, so would it be the same when the supply is perfectly elastic?
Yes.
Is that what you were thinking?
So let me just put what Jacob was talking about here. So these are kind of some extreme cases, since you brought it up. If demand was perfectly inelastic and we had some regular old supply curve, the old price was here, the initial equilibrium price was there. If we throw on the old tax burden and we float the wedge in, let me do a mini wedge here, I'll do the other side. We go in here, top part of the wedge touches the price that the consumer pays. The price that the producer receives hasn't changed. And so the whole burden, the whole tax is being paid by the consumer. Another extreme case that Jacob said last was, what if the supply curve was perfectly elastic and we had an ordinary old demand curve? And we float in our tax wedge, always staying above the supply curve, below the demand curve, until we get stuck in here. Now the price that the consumer pays is up here, and the initial price was here, and the price that the producer gets is down here. Boom, 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 boom. All the burden is paid by the consumer. Is that what you're asking? Yep. And then we could do the other extreme cases with the supply curve and do the same thing. I think some of those examples might be in your book. All right, any other last things? Okay, so we're going to talk about happiness. We're going to try to get you to your happy place. This is chapter 8. We are skipping 7. It's in your syllabus. What we just got, I said 4 and 5, didn't I? Sorry, I misspoke. This is 5 and 6 that we just wrapped up. Chapters 5 and 6 with the government policy and consumer surplus stuff. So chapter 8 and 9 kind of blend together. Chapter 8 and 9 look at the consumer in detail. We're going to build a happiness function. Let's build happiness. What? I don't think I've ever worded it that way. That's exactly what we do. Let's build happiness. Now that's got to sound absolutely crazy to some of you, that we're going to kind of make a little happiness calculator. But that's not too far from the truth, actually, of what economists attempt to do with this chapter and this material. So let's define a few things first, I guess. How do we do that? So we start with preferences. We assume, and this is the big one, number 1, consumers can rank preferences. Consumer can rank preferences. In other words, you're able to say, I prefer this to that and that to this, right? We can rank our preferences. That's one of our assumptions. And secondly, more is preferred to less. This usually isn't too hard to sell to our American culture. More, right? So more is preferred to less is an assumption that we have to make, that you prefer more goods to less goods. And by the way, one way of looking at that is that you have the opportunity to throw it in the garbage can or give it away to somebody else if you don't want it. So if you've had enough of it, you still have this more is preferred to less. All right. Finally, for the most part, our preferences are kind of reliable and stable over time for the most part. So these preferences are pretty stable. And then, as we go through an example, we'll see if that makes sense. But it's kind of like you don't wake up one day and you say, I love this. Next day you hate it. I love this, I hate it. And some of you might go through those emotions sometimes. But for the most part, our preferences over these goods and services that we desire are relatively stable. All right, so if we do this, my claim is that we can build a happiness function. All right, so let's see. How about, let's see if I got notes or if I'm going to have to wing this here. I've been known to wing it. There we go. Let's do this. So let's suppose there are 4 bundles of goods. So economists kind of refer to a grouping of goods as a bundle, kind of like a basket of goods. Suppose there are 4 bundles of goods, each with some pizza, M&Ms, and beer. Yeah, your breakfast this morning. Pizza, M&Ms, and beer. All right, so bundle A has 4 pizzas, 2 M&Ms, and 5 beers. Bundle B has 3 pizzas, 6 M&Ms, and 7 beers. C has 2 pizzas, 2 M&Ms, and 4 beers. And finally, D, bundle D has 6 pizzas, 6 M&Ms, and 5 beers. So what I'd like to do first is to have all of you rank these bundles. According to your personal preferences, whatever they happen to be, rank these. And what you want to do then is say, oh, okay, I get it. I like B is the best, and then C is the second, and then D, and then A. Or A, D, C, B. But take these sets and do this for your personal preferences. Look at what's in each bundle and tell me what your ordering is. Tell me what your ordering is. So go ahead, give you a minute or so to look at the bundles. There is no wrong answer, by the way. You look at the bundles and this is your personal preferences. All right. Yes.
Say it.
Nope, nope. Not yet. Let's see. I would like to have a sampling here. Give me a number between 3 and 8. 5. All right. Let's see how I did here. So I think this will work. 1, 2, 3, 4, 5. Why don't you go to the board and write whatever number you had. 1, 2, 3, 4, 5. 1, 2, 3, 4.